So let's talk about branches. See guys, first of all, why do we need branch? First, why we should create branch? I mean, what is the purpose of the branch here? So branch is getting created inside local repository, correct? Inside local repository. So when you commit, that file is going inside branch, correct? Okay, so what is the purpose of branch? Simple. So assume that you are attending one drawing competition. When you attend drawing competition, they will give one paper. This is a main paper in which you have to draw something and you need to submit, right? You need to submit. So what you did, you have drawn something till here. 50% of drawing is finished. 50%. But after that, you got two ideas. Okay, you got two ideas. Assume that two X and Y. But you don't know which one looks good. Okay, you got two ideas, but you don't know which one looks good. So when you'll come to know, if you draw that one, by seeing that, then you'll come to that, okay, this is looking good. So you have two ideas, but you have only one paper. So how you are going to implement both for testing purpose, right? So that time what you do, you take photocopy of that one, this paper. When you take photocopy, you take two photocopies. When you take photocopy like A and B, see that whatever you have drawn till that time, that you will find. Now you implement both ideas. One idea you implement here, another idea you implement here. Then you verify, okay, which one looks good. Assume that B is looking good. Assume. Then you implement that B part here. That means to implement new ideas, what you did, just took photocopy, then you implemented that idea, then you verified. Okay, once it is finalized, then you are implementing that good idea in a main paper and you are submitting that main paper. Correct? So here also same thing as that is the purpose of branches actually. That is, product is same. Assume that you are writing some code to create IRCTC application. So product is same. So for one product, we create one repository, but different tasks, different ideas. Okay. So different tasks means, see, simultaneously you want to work on multiple tasks. Like you are creating login and logout page. Then you are creating that, trains where you can see list of trains that page. So multiple tasks or multiple ideas. See, one page is there where you want to implement two ideas. You don't know which one looks good. Okay. So like that, either could be multiple tasks you want to do at a time, or in a one task only you have multiple ideas, but you don't know which one looks good. So in that case, what we do, each new idea or task has one separate branch. Okay. So what we do here, you can see. In local repository, by default, one branch will be there. So I am creating one more branch. So when I write code, that implement new ideas, I implement these here. I mean, in that new branch. Okay, to implement new ideas, and if you want to do multiple tasks, we create separate branches. That is the purpose. Because if I keep everything in one branch, that creates a lot of confusion, correct? That's all. Like, login page, entire code I will store in one branch. Logout page code I store in one branch. Like that. Or in login page only, I'm getting two ideas. I don't know which one looks good. So one idea, the related code I keep in one branch. Another idea related code I keep in another branch, like that. So product is same, one repository, but different tasks or ideas. So to implement each one, we create separate branch. Okay. Then finally merge that code of all branches. I mean, merging means if it is a new idea, then we take, for example, see, this is branch A and branch B. So in branch B, see, that's what merging means. In paper B, whatever idea you implemented, that is looking good. So that idea only you implemented in a main paper and you submitted. Correct? So here merging in the sense, what we do, we keep one branch. Let me show you. See, this is repository. Okay. This is main branch. main. I created two branches. One is branch A and branch B. So one idea related code I have stored in branch A. Another idea related code I stored in branch B. Now I found, okay, branch B's code is good. Then I merge branch B's code to main branch. Merging means copying the code from one branch to another branch. So branch B's code I merge into main branch. From that branch, I push to central repository. So we merge code. Not all branches, whatever branches code you feel like, that's good. That is all. Okay. Simple, guys. I'm repeating. To implement new ideas, or if you want to do multiple tasks simultaneously. So for that, we keep different code, right? So that code we store in different branches. Finally, we merge, okay, as per the requirement. Okay. So why are we creating branches? That is, one is for parallel development, because you are working on multiple tasks. Also, to implement new ideas. For that, we are creating branches. You can create any number of branches. There is no limit. There is no limit. The way here you can take any number of photocopies. That's up to you. There is no limit. Changes are personal to that particular branch. So whatever you do in one branch, other branch will not come to you until you merge. If you merge, then code will be copied to that branch. If you don't merge, then whatever you do in one branch, other branch will not come to know. Whatever you do in one paper, other paper will not come to know, right? Here also same. Changes are personal to particular branches. Can put files only in branches, not in repo directly. See here, when you commit, that file will go to branch only, inside repository branch. So you can't put something in directly repository. So you have to put in branches only. Okay. Default branch is main. By default, one branch will be created. That is the name they are giving as main. And you can create any number of branches. There is no limit. Okay. By default, they are giving one branch. By default, the name they are giving as main. Okay. The next point is, right, this one. This one you won't understand now. For that, I need to show practicals. Even if I explain 100 times, you will not understand. After showing practicals only, I will come back. I will explain this point. That time you will understand. Okay, so just ignore this point as of. That is the purpose of branches. Got it? You'll understand clearly. You know, when we do it practically, then things will be more clear. Workspace or working directory. This is the place where you work. Where you can see files physically, where you do modifications, everything. Version ID, commit ID means when you commit means sending that file from staging area to local repository, that to inside branch. So every time you commit, you will get one commit ID that either you can call version ID, commit ID. That is a reference to identify each change and who did that change. That means, see, when you commit, see, you added some more data and you are committing. Observe carefully here. So you did one transaction. Today, assume that I have sent you 100 rupees. You'll get one transaction ID. Tomorrow, I'm going to send 200 rupees. I'll get one more ID. So this ID shows, transaction ID, reference ID shows what is the amount, who did the transaction, at what time he did the transaction. Correct? The transaction reference ID contains complete information, amount, at what time, from where to where, which bank to which bank, everything. So here also same thing. Commit ID contains the data. See, after modifying that code, I'm committing. So every time you commit, you'll get one commit ID that contains the data, whatever you are committing. And also who is committing? Mr. Sai, his name, his email ID, and what time we are committing, everything will be there. So commit ID shows it refers to each change. Change means whatever extra data you have added. See, this is, okay, first line. I have added committed. So I got one commit ID. That commit ID contains the data of first line. Then after that, I have added some more data, added committed. So second time when I commit, I'll get one new commit ID. That new commit ID shows that contains data of second line. Like that. So that means whatever change extra you added, it shows that data. So it's a reference to identify each change and who did the change at what time, everything. Tag means what? A meaningful name we are giving to commit ID, because we can't remember commit ID. Commit ID contains 40 long alphanumeric characters. So we can't remember it. That's why we are giving a tag. Okay. So yeah, just remember these terms. Okay. When I show practicals, that time things will be very, very, very clear. Now, why are we using Git only? Why are we using Git? Why? Because, see, before that, let me tell you one more thing. You might be thinking here, Sai, we are creating file. Why we need to add and commit? What is the purpose? First of all, why we need to add, why we need to commit? When you commit, that time only, that will be stored in the form of commit IDs. We need the data in the form of commit IDs. Okay. Now you will understand now. Now you will understand here in this. Here you will understand. So why we need only Git? Because of 3 reasons. See, you can use other tools also, so other source code management tools. But why only Git? Because here we are getting some advantages that you are not getting those advantages in other tools. The first one is Git is pretty fast. Why it is fast? Because of snapshots concept. I'll tell you what is the snapshot. Simple. See guys, there are 2 types of snapshots. One is whole and one is incremental. Snapshot means what? Backup. Snapshot means backup. So whole backup, incremental backup. 2 types are there. See, this is a file. File A. In that I kept some data. Okay, I kept some data. When I keep some data, actually, see, these are storages. Okay. When I store that one in both, both storages, one is whole and the one is incremental. Then here, that file will be stored here in whole, in this storage with that line. Here also, that will be stored in that line. 2 types of storages. One is, one storage A, storage B. Storage, assume that storage X, storage Y. So X takes whole backup. Y storage takes only incremental backup. So what is the difference between whole and incremental? That's what I'm explaining. Now, first time when we copy, both will take that file with the data. So second time, see, when I add some more data in that file, again when I store this whole backup, right? It will take that file again with that first line, then second line. But incremental backup, what it does, it will take in that file, it will take the backup of only second line. No, it won't take complete backup. Again, see, I have added one more line. Again, I stored. Okay, again, I have stored that file. When you store in whole backup, it will take that file with that first line again, second line again, third line again. But in incremental, in that file, it will take only third line. See, assume that each line size is 1 KB. That means my actual file size is 3 KB. In whole backup, how much space is occupying? Here 3, here 2, 1. Total it is occupying 6 KB. But in incremental backup, it is taking only 1, 1, 1. It is taking only 3 KB. Correct? That means whole backup means when you store, every time it takes complete backup every time. But incremental, whatever extra data you have added, it will take only that backup. That is so. Okay. Now here each copy we call as version, or you can call snapshot. See here, version 1, version 2, version 3, like that. Here also version 1, version 2. Either you can call version or you can call snapshot. So here Git follows incremental backup. But other source code management tools, they follow other tools, they follow whole backup. So Git is not consuming much space because it is taking only incremental backup. Okay, that's why it is pretty fast. See here only 3 KB. See, one person is there with 150 kg. Another person is there just 50 kg. Who runs faster? 50 kg guy can run faster. Correct? So that's why here also, since Git is taking less space, that's why it is pretty fast. Less space means how it is taking? Simple. See, this is a file. I kept some data. I have added and committed. When I add and commit, that file is there. Later on, I have added some more data. Added and committed. When I add and commit, see here, first time it is taking that yellow color line. Second time when I add and commit, it will take only pink color line. Again, I kept some more data. Added, committed, it will take only blue color line. See, it is taking just incremental data that is getting stored in local repository. Now see, every time we commit, this will be stored as a version 1, version 2, version 3. Okay, these you can call versions. Also, you can call commits or you can call snapshots. Guys, here 3 words are there. Either you can call version, or you can call commit, or you can call snapshot. Okay. So actually we need, see, suppose after that if I delete these 2 lines, assume that in this file I have deleted these 3 lines and I kept one more line, red color line, assume. After deleting in the workspace, I kept red color. Again, I have added and committed. The red color will be stored as version 4. That means, see, even every time you modify and commit, the data is getting stored in local repository in the form of commits. So actually we need the data in the form of commits, or you can call versions or snapshots, so that at any point of time, you should be able to go back and you can get older data. That's why I said, you might be having website. Already we are storing that file in Workspace. Why we need to add and commit? Because when you commit, then only it will be stored in the form of versions. So that at any point of time, we can go back and we can get older data. Okay, getting older data is not possible in Workspace, but that is possible in here, local repository. That's why we need that stage. Understanding, right? That is so. Yeah, right? So that's why Git is pretty fast because it takes only incremental backup. But other tools that are taking whole backup, they occupy more space. That's why Git is pretty fast. Parallel branching, yes, you have multiple branches. Okay, other tools, you don't have branching strategy. That means you can't implement new ideas and you can't work on multiple things. But in Git, yes, you have branching strategy. You can create any number of branches. That means you can work on multiple tasks simultaneously. That second advantage in Git. Fully distributed means, see, fully distributed in the sense, this is my local repository. This is GitHub. This is someone's local repository. This is someone. Okay, team A, team B, team C. GitHub. Now team A written 10% of code. After that, they are going to push, that 10 will go here. C and B, they are pulling. So that 10% will be here. Assume that C added 10 more percent. They pushed. So it will become 20. A and B both, they pulled 20. That means, see, suppose if I lose my central repository, no problem. Because that data is available in A's machine, B's machine, and C's machine. So backup copy is available in multiple locations. That's why it is fully distributed. Backup means in the form of commits. So those commits are available in each and every one's machine. So that's even though if you lose central repository or anyone's repository, still we can get the data from others. That's a backup is available in multiple locations. That's why it is distributed. No need internet connection, so no network latency. See, even though internet is not there, still it will not stop your work. Assume, see, Git we can use in our laptops also. Okay, laptops also we can use. You can see here, I have installed Git. You can see. I'm going to show you. Git is already there in my laptop. So in your laptop, so you want to copy from things from your C drive to D drive. If you want to copy something from C drive to D drive, do you need internet? No, I don't need internet, correct? Even the internet is not there, still it will not stop my work if you want to copy something from C drive to D drive, correct? Here also same thing, no need internet connection. That means if you want to add, if you want to commit, you don't need internet. Okay, you need internet only when you push to central repository. That too just for fraction of minutes, seconds. That is enough. Assume that internet is not there. Still in your laptop, happily you can work. You can write the code, you can add and commit. At the end of the day, when you get internet, you just push. That means no network, no internet connection, so no network latency. That means it won't latency with network delay. Okay. So even though if internet is not there, it won't stop your work. So no problem at all. Rarely you need internet. But in other tools, after writing code, immediately you have to push to central repository. Because in other tools, you don't have local repository. That means you can't store the data in commits in local machine. So you need to store it in central repository only. That time in other tools, you need internet connection every now and then. But in Git, not required. It won't stop your work actually. At the end of the day, just you need internet connection for a couple of minutes just to push. But in other tools, you need every now and then. That's it. No need central server separately. See guys, I told you, right? GitHub, this one. We push, pull and all. Actually, the central GitHub is not required. If I want to share to someone, I can share like this. But that is not a good practice. That's why I'm not doing that. But yes, even though if you don't have central repository, still you can use. You can share code directly to others. But that's not a good practice, right? That's why we are using central. But actually, no need. Each workspace will have its own repo internally. See here, this is workspace, staging area, local repo. Each workspace will have its own internal repo, correct? I mean, this workspace is having its own internal repo, right? Okay. But other tools, they don't have local repository, I said, right? That's why you can't store the code in the form of commits. So in other tools, every now and then you have to push, but that in Git, that is not required. Because every workspace is having local repository, we can store that code in commits format, local. Can create any number of branches, there is no limit. You can create any number of branches, that is up to you. There is no limit. Can share code without using central repo, that already explained. Without central repo also you can share, but that is not a good practice. So that's why we call Git as distributed version control system. Why we call as a version control? Because every time you commit, that would be stored as a new version, or you can call commit, you can call snapshot. So that we can go back to older version, we can get older data anytime, right? So we are controlling versions. We are storing the data in the form of versions. That too, those versions are stored in distributed locations. In my machine, in your machine, in central repository, in a distributed locations, we are storing all versions. That's why we call Git as also distributed version control system. And also you can call Git as source code management tool. Why? Because we are managing the source code, right, by using Git. That then now the source code only you are managing, right? So that's why either you can call version control system, distributed version control system, or source code management. Okay. See, these are difference. Git subversion is a older tool. See, in Git workspace, okay, staging area here they are not showing, but that is a workspace and having its own local repository. Correct? You can see there we are storing data in the form versions, version 1, 2, 3. Other B machine also workspace, it's local repository, and central repository. Anyways, we are storing in versions. So even if I lose any one machine, the data is available in the form of versions in everyone's machine. But that is not the case in SVN. See, since in SVN they don't have local repositories, they have to store that data in the form of versions in central repository only. If we lose central repository, then we lose all versions. Correct? So SVN we call centralized version control system because data is getting stored in only centralized location. But Git we call distributed version control system because the data is getting distributed in many locations. So even if you lose one or two, there won't be any issue. Okay, that's it. So snapshot means that's what backup copy, right? So when you add and when you commit, that the copy data, the change will be stored right here. You can see when you add, when you commit, that will be stored here. That is what backup copy we call. This you can call either commit or version or snapshot you can call. So why we are storing that one in the form of versions? So that we can get any previous version, any backup, previous data we can get. So each snapshot represents some data of particular time. Now I am committing. So when we commit, you'll get one commit ID that represents data of today's date, today's time. Now, see, every time you do transaction, online transaction, that transaction represents the amount of particular time. So particular time you are sending that amount. So here also it represents the data of particular time. Okay. So stores it changes, only extra data, not the whole backup. I told you, right? Every time you commit, it takes incremental backup, not complete backup. Commit. Yeah, that's what. Store changes in local repository. That's what we call commit. Every time you'll get one, every time you commit, you'll get commit ID that already explained. That contains 40 long alphanumeric characters. Commit ID contains. On what basis this ID is getting generated? Actually, see, in Linux instance, there is a tool called checksum. In every Linux instance, you'll get one tool called checksum. What is the purpose of checksum? The purpose is it will generate one binary value. That means any number. On what basis? Equivalent to the data present in the file. So randomly it will generate one value based on the data present in the file. Okay. So every time you commit, that commit will have that particular data. Based on data, it will create 140 long alphanumeric one ID. Okay, that's all. So that's why that means out of 1 lakh lines, even if you add one dot, that means you are modifying the data, so ID will be modified. If you remove one dot, you modify data, means ID will be different. See, even if you change one dot, ID will be different. By using that, we can track changes. Yes, ID got modified means someone did something. That is so. Okay. And yeah, stages in Git. We have total 4 stages in Git. Total 4 stages. You can see. Workspace, staging area, local repo, central repo. Correct? So workspace is a place where we create files, where you modify, where you add some data, where you create file, where you modify. Staging area. See, after creating file, we add to staging area. So first of all, why we should add to staging area? When you add, that file will go to staging area. So the staging area is a buffer area. Buffer means it is the area between 2 different zones. So it is the area between workspace and local repository. Between in the sense, it is not necessary that it should be exactly between. To send a data from workspace to staging, workspace to local, it has to cross staging area. That's why we call this one as a buffer area. Means it's the area between workspace and staging area. sorry, workspace and local repository. The purpose of staging array is it takes snapshot. See, what actually happens when you add, that data will go here. So here actually snapshot will be taken here. For that file, it will take the backup copy. When you commit to that backup copy, one ID will be allocated and it will be stored. That means actual snapshot will be taken in staging area. When you add some data, when you put some data, when you add, so when you add whatever data you add it, right? For that here one backup will be taken. When you commit to that backup, one ID will be allocated and that will be stored permanently in local repository. So it is a place where snapshots will be taken, backups. Local repository means, so one snapshot is ready, to that one ID will be allocated and it will be stored permanently locally. See, store changes locally. Central repository, store changes centrally. When you push, store changes centrally. Okay, that's all. So workspace is a place where we create files. Staging area is a place where snapshot will be taken to that file or the data. Local repository is a place where ID will be allocated to that snapshot and will be stored locally, permanently. Central repository means it's a place where these commits will be stored permanently, centrally. So that that will be available for all. So these are the 4 stages in Git. Okay, 4 stages in Git. So here, if you send data from here to here, we call add. From here to here, if you send, that we call commit. Here to here, when you send data, that's what we call push. So add, commit, and push. Okay. So these are the 3 things. Generally, how many types of repositories are there? I told you that only we have 2 repositories. One is local, central. Local repositories also we can call non-bare. Central also we can call bare repositories. That's the end name they are giving. Either you can call central repository or bare repository, or either you can call local repository or you can call non-bare. So local repository means, I told you right, when I compare local with central means this entire folder is local repository, this is central. So the purpose of local repository is where you can create files, where you modify and all. See, I'm creating files, modifying and all. So that modifications and all you do in local repository, means in local folder. The purpose of central repository is to store the data. See, I'm pushing, right? Then we share to others. So for storing and sharing, we use central repository. We won't work in central repositories. No, we work in local repository. Central repository purpose is just to store and share. Okay. So this is just introduction theory for Git. Okay. So still many things we need to discuss, that we will do it while doing lab practicals. Okay. Even if you get any doubts today, no problem, because tomorrow next class I'm going to jump into practicals. There I'm going to do it all these things. Practically I'm going to show you. Then I'm going to explain many more things. Then all your doubts will be clarified. Today I just introduced these words. What is local repository? What is push? What is put? Just introduction. And this diagram I'm going to draw separately with the tools properly. So that I'm going to share the diagram also, so that you will understand things easy. Okay. So these are theory of Git. In next class, we are going to install Git. I'm going to show you this entire workflow. Apart from this, we have many other topics in Git. All those things we are going to learn one by one. Okay. Yeah. For next couple of days, we are going to spend our time on Git only.